Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 5 from the June 2010 Edexcel GCE Mechanics 1 paper. This is actually also, the whole paper is actually the specimen paper for the new specification. It's like the sample assessment paper for the new specification of M1, which was released, I think, in 2019. So basically, there's been not really any change in the specification. They just put an old paper for the specimen paper, the sample assessment paper. People have been asking me to do that paper. Well, this is that paper. This is that paper, June 2010. Okay, this is also the sample assessment for the new specification. All right, now anyway, so two cars P and Q are moving in the same direction along the same straight horizontal road. Car P is moving with a constant speed of 25 meters per second. At time t equals 0, P overtakes Q, which is moving with constant speed 20 meters per second. From time equals t seconds, P decelerates uniformly, coming to rest at a point X, which is 800 meters from the point where P overtook Q. From time equals 25 seconds, Q decelerates uniformly, coming to rest at the same point X at the same instant as P. Sketch on the same axis the speed time graph for the two cars for the period from t equals 0 to the time where they both come to rest at the point X. So it seems like a lot of stuff there to go through. Okay, it's like a lot of words there in this question, but we have to just break it down step by step and we'll get there. Okay, it's not difficult. So here we're going to have our speed and there our time axis. Okay, so here we have speed in meters per second, and here we have time in seconds. All right, so now basically they at the same time with time equals 0, they're going to be in the same place. Okay, because it says that P overtakes Q at time equals 0. And at the time when that happens, P is moving at 25 meters per second and Q is moving at 20 meters per second. So if we look at P, so I'll just mark those. So let's just say this is 25 and just say this is 20. Okay. Right now, it says that P is moving with a constant speed, P is moving with a constant speed of 25 meters per second. So P is moving with a constant speed of 25 meters per second. So I'll put that like this. That's P. And Q is moving with a constant speed of 20 meters per second. So Q is moving with a constant speed of 20 meters per second. Right, that's what's happening in the beginning. Then it says from t equals t seconds, P decelerates uniformly. So let's say this is where time t occurs. So I'm going to call this time t. Okay, so this is what I'm going to call t. All right, this one, P starts to decelerate uniformly to rest. Okay, so, whoops. Decelerates uniformly to rest, let's say, over there. Okay, so that's P. Okay, this is going to be the point X. Okay, and the distance from the point where P overtook Q, which is here, is 800 meters. So the area under the whole of this trapezium is 800 meters. Okay, I'm going to make this a bit higher actually because it doesn't. I think it'll be better. Okay, just say that's 20. That's 25. Now, as for Q, from time equals 25 seconds, Q decelerates uniformly, coming to rest at the same point X at the same instant as P. So 25 seconds, which we don't know where it is in relation to this T. Is it before the T? Is it after the T? Is it before this point? Is it after this point? Actually, we can know. Because what we know is they both started at the same place when they were overtaking. This is being overtaken. And they both ended at the same place. They both ended at the same place. Okay. So you can see here that P overtakes Q, which is moving with a constant speed of 20 meters per second. Okay. So So P is moving at 25 meters per second, and Q is moving at 20 meters per second. So P overtakes Q. So this is Q, this is P. Okay. So this is P, and this is Q. So P overtakes Q at this point. So they're at the same place at the same time. And they both come to rest at the same point here. So that means they cover the same distance. So for example, if I was to continue this until there, like this, let me make it the right color. Okay, if I was to continue this and make it come to rest there, there would be a problem. The area of the trapezium in black would be greater than the area of the trapezium in blue. And we know that the area under the speed time graph gives us the distance traveled. And we know that the distance they've traveled is the same. So I have to extend this further this way such that it's possible for the areas to be equal. If this area here now is the same as that area here, then these two areas they'll have the same area. So this has to kind of come on the outside of that because it's lower down than it. So it has to make up for, the area has to be made up for on this side. So it definitely, the time, 25 seconds, has to be somewhere on this side. Okay, that's what a lot of students are confused about here. But the time has to be, 25 seconds has to be somewhere over here. It has to be somewhere past this intersection of these two lines. Otherwise, the areas won't be the same. Okay, now for part B, it says find the value of t. So we're going to find the value of t. So here we have basically two trapeziums. I mean, the one that I put in with the black line is representing P's journey and the blue line representing Q's journey. So I'm going to make a little sketch of them down here. Okay, so let's look at Q's journey first, because I think we can do something with Q's journey. So we've got this trapezium that looks something like this. Okay, and what we have here is we have that the height of the trapezium is 25, and the side, this longer side here, the shorter side here is if we look at Q, this is 20, and this is 25. And here we don't know what it is. Let's call this X. Okay, this is the length of the larger side. Why am I considering the shape of a trapezium? Because we know that in a speed time graph, the area represents the distance traveled. And we know that the distance traveled in this case, as they told us in the question, is 800 meters for both P and Q, both of them. They both traveled the same distance. They were in the same place at the same time. When T was 0, P was overtaking Q, and they were at the same place at the same time when they came to rest at this time, which we don't know. So what I've done is I've called this X. I know that the area of this trapezium is equal to the distance traveled, so you can say that's equal to 800. So we know for a trapezium, the area, the classic kind of formula that you normally get is half times A plus B times H. I like to say H over 2 times A plus B. Okay, same thing. So the H here represents the distance between the parallel sides, which is 20 here. So we can say 20 over 2 times A plus B. Those are the lengths of the shorter side, so 25 plus X, and that's going to give us 800 meters. So this gives you 10. 800 divided by 10 is 80. So we're left with 25 plus X equals 80. So X is 80 minus 25. Now 80 minus 30 would be 50. So 80 minus 25 is 55. So I know that this is 55, this length of this longer side. And that's the same length. This is now, we now know this is 55. So if we look at the other trapezium, the one for P, so if we consider P now, we have a trapezium that looks like as follows. Okay, it's 25, so it's a bit taller. Okay, and it goes on for a bit less, and then it stops at the same time. Okay, something like this. And for P, we know, as we said, the height, the vertical height, these are the parallel sides. The vertical height is 25. The length of this line we just worked out is 55. And we want to find what T is. T is the time for which it was traveling at constant speed. Okay, this T over here. Okay, that's for the journey of P. We know the area is 800. Okay, so we can use exactly the same formula. Area of a trapezium. This time the thing that we don't know is this T on top. And that's what we have to find. So we can say that the height, 25 over 2, the height over 2 times the sum of the parallel sides, T plus 55, is equal to 800. Okay, so we're going to have T plus 55 is equal to 800 times 2 over 25. And so we can work that out. Okay, so you have 800 times 2, which is 1600, divided by 25. That gives you 64. So you have T plus 55 equals 64. So T is equal to 64 minus 55, which is equal to 9. So T equals 9. That's the value of T. All right. So it says T seconds. So the unit's already assigned there. So T is equal to 9. So there's the answer to this question. It's 8 marks for that second part, which seems a lot. Doesn't seem like there's that much to do, but that's fine. So the main problem with this question is people don't know where to put this. Okay, but you have to think about the fact that the area of these two must be equal because they've traveled the same distance in the same time. Okay, so this has to have a bit that's going beyond here, because if you stop it before this, then the area will be less because it will be completely contained within the big trapezium. So the trapezium has to be such that there's a bit sticking out here, so the area makes up for the area on that side that is more. Okay, so that's the main catch in this question that I think many people had issues with, but otherwise it doesn't seem too bad. As I said, this is a question from the June 2010 paper, and it's also a question. This June 2010 paper was basically the sample assessment paper that they put for the new syllabus, which shows that the new syllabus for M1 isn't really any different from the old syllabus, which shows that you can practice from many of the older papers for the new specification. Anyway, that concludes this question. Other questions from this paper can be found in the playlist that will appear on the top right of the screen at the end of this video. Other questions from the topic of travel graphs you'll find in the playlist over here. And you can subscribe to my channel by clicking on this link. And the video here will show you how to use my channel to find what things you might be looking for. Thank you for watching, and see you